Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to study about the temperature effect on the polymers. Polymers are extremely hard, they are rough and they are damn solid. Now when I mean that the structures of them are very complex. The only thing that can have an effect of it can be temperature. And again, temperature will not change the chemical properties of it, but temperature may change the physical state of it. For any other solid, when it's heated, it will turn into a liquid and then it turns into gaseous state. But polymers are extremely strong when it comes to their structure. So they do not have this solid liquid gaseous curve. They have a different curve, and this curve will be studied in today's session. Let us see the effect of temperature on polymers. The hard and the brittle state of glassy state and soft flexible state is the viscoelastic state. Now there are two states which are defined over here. For any normal substance, the two states are solid and liquid. But over here, we have first state which is defined as the glassy state. The second state is defined as the viscoelastic state. Now glassy state is the state wherein generally we will find all our polymers at room temperature. They are hard, and brittle. So hard and brittle is considered to be the glassy state where they are generally being formed. The another state is the soft flexible state, also known as the viscoelastic state. Viscoelastic state happens or appears when you provide some kind of energy to that polymer. Generally, this energy is in the form of heat. That means increasing the temperature of the polymer leads to the formation of viscoelastic state from the glassy state. If viscoelastic state of the polymer is heated further. So now what happens over here? We have discussed the first two states of it. The first was the glassy state, the second was the viscoelastic state. But now after obtaining or after getting the viscoelastic state, you heat it further. You apply more heat to it, you give more energy and rise the temperature of further, and you get the third state of it. The polymer becomes a viscous liquid and flows. Over here, students, it's very important for us to understand that the third state is the liquid state. For all the normal substances, the first state is solid state, second state is liquid state, and the third state is gaseous state. But over here for polymers, the first state is the glassy state, the second state is the viscoelastic stage, and the third stage is the viscous liquid stage, also known as the flow stage. That means over here the third state will be the state of liquid. The first stage is the state of the solid, that is my glassy state. The third state is my liquid state. Then what exactly is my second state? What is my viscoelastic? Viscoelastic is a semi-solid kind of a substance which shows elasticity, also shows some kind of solid structure. That means at viscoelastic state, there will be elasticity in my polymer. There will also be a solid structure in my polymer. The polymer will not flow. The polymer will not stay rigid. It's a state between the solid and the liquid state, and that state is known as my viscoelastic state. This is known as the viscofluid state. Over here, they have just given a diagram. Over here, I have the states. First is glassy. Second is viscoelastic state. The third is viscous fluid state. Now when you're flowing from here to here, or when you're moving from this direction, that is my glassy direction, to the viscofluid direction, what happens is you are applying heat. Whenever you apply heat, the glassy state will change to my viscoelastic state. The viscoelastic state will change to my viscofluid state. Whenever you are removing heat, removal of heat will change from this end to this end. So what happens over here? When viscoelastic state is further cooled down, it becomes my glassy state. Over here I have two temperatures. This is my Tg and my Tm. Both these temperatures are very important. Tg is the temperature where the glassy state gets converted into viscoelastic state. We had melting points and boiling points in our normal solid liquid gaseous states. In the same way, instead of melting points and boiling points, we have Tg and Tm. Tg is the temperature wherein the glassy state will go and get converted into viscoelastic state, and Tm is the point wherein the viscoelastic state will get converted into viscofluid state. Now let us see over here the examples of different polymers, the Tgs of them and the Tms of them. The first first polymer is my polythene. Polythene is my normal, most commonly used plastic. We get polymer bags of it. The polymer bags are extremely fragile. You can easily break them off and tear them off. Why? Because they are not in the glassy state. At room temperature, they are at viscoelastic state. So if I have a polythene bag of a plastic or a polythene which is extremely thin, we can easily tear them off. Why can we tear them off? Because they are not glassy, they are not brittle, they are not very hard. At room temperature, polythene is at viscoelastic state. So at what temperature it will get converted into a glassy state? It is minus 125 degrees Celsius. When I keep polythene at minus 125 degrees Celsius, it will get converted into my proper glassy state. What happens if I apply heat to it? If I give heat to it at around 115 degrees Celsius, the entire polythene will melt and it will become liquid. Same as with polypropylene. Now what is the difference between polyethylene and polypropylene? If you see over here, between polyethylene and polypropylene, there is a difference of just one carbon. Ethylene is 2 carbons, but propylene is 3 carbons. But there's a vast difference between the TGs and TM values. Over here I have minus 125 for TG, over here I just have minus 18 for my TG. And for my TM I have 115, and over here for TM I have 175. Polystyrene is nothing but my styrene molecule. Styrene is a benzene ring, and on that benzene ring I have a C double bond C. To get TG we have 100 degrees Celsius. For TM we have 240 degrees Celsius. Polyvinyl chloride, PVC, it is one of the most commonly used plastic for making pipes which carries water. For PVC I have TG as 80 and TM as 212. And finally we have polyacrylonitrile with TG as 97 and TM as 241. So over here in today's session we studied the effect of temperature on polymers. We studied the 3 of the most basic states. The first state was the glassy state, second was viscoelastic, and third was viscofluid. We also had an idea about the TGs, TMs and different values for different polymers. Thank you so much for watching this video. Stay tuned to Ekeeda and subscribe to Ekeeda.